Hi, welcome to Math as a Language. In today's video, we're going to start our first topic in geometry, our first of a series of discussions of geometry and geometry topics, and we're going to begin at the beginning. Let's start even before that. We briefly talked about why place geometry more often than not. In most curriculums, you have Algebra 1, geometry, then you go to Algebra 2. And in an earlier video, and we're just going to briefly touch on it here. The question was why that placement, and as we discussed, and we'll review here, in algebra, actually, the topics, the rules, the postulates that govern the algebra, they exist. It's just that in geometry we highlight those. That is to say, so in algebra, a real quick statement: if you have 2x plus 5 is equal to, let's make it, I don't know, 17 or something, okay? And you have to solve this equation. Then, of course, you'd go ahead and solve it. Just subtract 5 from both sides here. And so then we'll have, what's that? We'll end up with so 2x subtract 5, so that's gone, would be equal to 12. And at this point, we're going to go ahead and divide both sides by 2. And divide both sides by 2, and x is 6. All right, and a very basic algebraic equation that we had to solve. The point we want to make, though, is, and we have made, and we'll review here, is that in algebra, these rules do exist, but we don't emphasize the rules. More often than not, we just talk about the answer, the solution x is 6. That's the solution of the value of the real numbers, which would make the statement true. The thing that we want to recognize here, and we'll again repeat, in geometry, though, these rules, the reasons for the statements is highlighted. That is to say that we want you to recognize that mathematics is a language, but it's built upon definitions and postulates and rules and corollaries, and there are reasons why we operate within that language. That language has structure, if you will. And so at this point, if you were to, in a geometry, we emphasize the fact that this is the subtraction property of equality. So that becomes the point, or an emphasis of the geometry, the subtraction property of equality, and you need to state that reason as to why you can subtract 5b from both sides, and here too, this would become the division property of equality. All right, and you would have to state that reason. So a lot of it's, and again, at this point of equality, you want equality there. Okay, but at any rate, the point is the reasons. These reasons, these justifications, you have your statement, and these reasons, the laws, the properties, these reasons become the emphasis in the geometry. All right. Now, it's an interesting thing. Interesting aspect of it is, even though we know we have all these corollaries and rules and properties, interestingly enough, most Euclidean geometry, and Euclidean just means that it's adhering to the principles and the writings of Euclid regarding the laws of geometry. Most Euclidean geometry, after all said and done, even though we have all of these properties and rules, they start have an interesting beginning. In geometry, more often than not, we start with 3 undefined terms. So even though the geometry would be built on laws and properties and rules and corollaries and theorems and all the rest, it's interesting. I think it's pretty interesting. We think it's pretty interesting that, for the most part, we start that long journey of geometry with 3 undefined terms. And so let's do that at this point in time. Now, the first of these undefined terms, believe it or not, so we're going to have to kind of walk a fine line here. We're going to kind of describe the terms and perhaps depict them, but they're not a definition. They're intuitive. Okay, so let's go with the first of them. The first undefined term is of a point. Now, what's a point? A point, of course, intuitively, it would look. We're gonna make this a little bit larger. Well, let's get to the point. Not to be coy or cute here, but a point would be a dot. That would be a point. Now, that one you may not be able to see, so we're going to make it a little bit bigger. So that would be the point. Now, here's the thing. Regardless of the size that we make these points, and we make them so large enough so that you can see them, please note that whether it's a super tiny point like this that you cannot see, or a larger point like this, the point has no volume. One of the things about the point, when we talk about the point, yeah, this point, the point has no volume, has no volume. So you can't really say that this point is bigger and or thicker than this one. I mean, obviously we made them different sizes that you so that you can see them. But beyond that, they have no volume. There's no numerical size related to the points to say that this point is twice as big as this point or another point. The point, again, it's not defined. It's just a concept, and essentially a point is a dot, and you can vary the size of the dot as we've done in this case, as the need for you to see them or to visualize it. But beyond that, one point is not bigger or thicker or twice the size or has any measurable relationship to the other point, if you will. All right. Now that's your first undefined term that we explain, but we don't define. Let's go on to our second undefined term. The second undefined term is, and it's intuitive though, that these points, all of these points, and we're going to make them again larger just so that we can see them. But what we want you to recognize is that you have this point, and then you have another point, you have another point, and infinitely many points. Now, all of these infinitely many points, as you stack them next to each other to get to the heart of it, those points would end up forming a line. All right. Now, when we say a line in Euclidean geometry, we're talking about a straight line. Okay, it's understood that the line is straight. It's a straight line. So not a curved line, but a straight line. And this line is made up essentially. An explanation, as I was about to say definition, but an explanation as to what the line is. We could say that this line is a collection of points. So a line in Euclidean geometry is a collection of points. So you can see how this is going. You have your points, these points. You put them together, you collect enough of them next to each other, if you will, and you collect them and you put them next to each other, all stacked perfectly straight, and you end up with a straight line. So the points become a line, and let's get on with the third one. The third undefined term would be where those lines now, okay, the third one, these lines, if you have lines, infinitely many lines, imagine this, visualize it. You have all these infinitely many lines all over. They don't have to be perfectly straight or parallel, but you have these lines, infinitely many of them. Notice that you always put arrows at the end of the lines. As you stack those lines or mesh those lines, if you will, together onto this surface, all right, then you can establish the third undefined term, and that third undefined term is the plane. All right. So simply put, your lines are all, again, they are all at the same level now. They're all on the same levels, and they become a plane. So your points become lines, straight lines only. The lines become planes, and therefore, continuing with the definition, your plane, therefore, and again, the plane, your plane would just be a collection of lines. Not the best way of putting it, but it essentially it's not an improper way of putting it either, because again, remember we're talking about three undefined terms. At any rate, and these undefined terms, these are more explanation as opposed to definitions. So at any rate, let's conclude it at this point. Even though geometry, Euclidean geometry, has lots of postulates and theorems and rules, and it becomes the highlight of the geometry, for the most part, though, that entire system, the system of geometry and all of these relationships, these theorems and corollaries and postulates that you will learn and study and understand how they relate. It's interesting. I think it's interesting. We think it's interesting that this house of geometry is built upon three undefined terms, and those three undefined terms are your point, your line, and finally your plane. All right. Interesting. Point, lines, planes. And we'll continue this discussion in future videos, and we look forward to seeing you then. Take care.